No sitten, vuorossa on tässä ohjelmassa keissi-esittelyt, ja niitä on täällä ohjelmassa 8 kappaletta, mutta nyt live-elämässä niitä on 1 vähemmän sairastapauksen vuoksi, niin tämä ensimmäinen koulujen kulttuurisuunnitelmista kertova, niin sitä ei ole tänään, vaan tämän esittelyn aloittaa Aalto-yliopiston Media Factoryn esittely. Ja täällä on Ali Neissi, joka tulee kertomaan, että miten Otaniemessä Fab Lab-studiossa oppilasryhmät voivat käyttää muun muassa 3D-tulostimia. Sillä aikaa, kun Ali tässä valmistautuu, hänen esityksensä on englanninkielinen, niin katsokaapa näitä sivuskriinejä. Sinne on valmisteltu kuvia työpajoista, tunnistatte siellä ehkä itsenne. Eli tällaista on tapahtunut eilisen ja tämän päivän aamupäivien aikana. But okay, Ali, please tell us about Fab Lab. What is that?
Okay.
This is just a quantum leap forward.
It allows us to take what's on the computer screen and turn it into a real-life physical model in a matter of hours.
There is very much a wow factor.
Really changes the way we think about production.
Being able to make a difference and leave my mark is really what inspires me.
This is one of those industries that matches perfectly with 3D printing, additive manufacturing, because we need custom everything.
Client can come in and see that we're not just one of 8,000 processors, that we actually invested in technology that makes them better, differentiates us from everyone else.
Now we've got a 3D Fenway Park. This came off a printer. Is that what you're telling me? Believe it or not, it's a 3D printer that jets on resin that turns into a plastic when it's done. By having this 3D printer, we can have a very, very short turnaround time, more than any other company in this field.
You can rapidly prototype complex products without the need for the major capital investment in a production line.
The technology affords you the ability to actually get back one resource in this world you can't buy, and that's time.
It allows our students a lot more hands-on opportunities, and they can take the object and they can test it, and they can see the theory being supported by the actual physical results. You know, that type of information is priceless. You guys are really on the cutting edge.
They can take it into the big boss at the company. Here you go, boss. We've got a great new system. We're going to sell 1 million of them.
There's really no words for me to describe how cool it is.
Stratasys is able to take a CAD file, we can import it into the machine and print a part in hours.
You can redesign the part to take advantage of what 3D printing can really do, which is very complex geometries that just can't be made by any other means.
We're working with Stratasys. What we're trying to do is take their technology and go from prototyping to real manufacturing. You can make parts, you can make systems that can't be made any other way.
This was a 3D printed model.
That is absolutely incredible.
Having this technology here was a game changer. It was the difference between killing a program and keeping it moving forward.
Hello everyone. This is Ali from Aalto Media Factory, which is located in Taik. And then there is one part of Media Factory which is called Fab Lab, and I'm working for that. As everybody noticed, I'm going to talk about 3D printing today, which is a term for that is additive manufacturing. First, I'm going to tell you what is additive manufacturing, and then I'm going to go on. For doing the additive manufacturing, first you need to have a 3D model. You can use one of the CAD programs, which is called computer-aided design, and then after that, save it as an STL file, then send it to another program which can slice it to layers, and then after that, send it to the printer, and printer will be printing that layer by layer from the bottom to up. In this slide, I can show you that why it is called additive manufacturing, and you can see that it is a difference between subtractive manufacturing and additive manufacturing. In subtractive manufacturing, like CNC milling machine, you have a big material that the drill goes in and try to remove some stuff in order that you get your shape. But in 3D printing, like additive manufacturing, you just add stuff layer by layer, and then you will reach your target. So it's really cool. And there are two technologies which are really important in additive manufacturing. I'm going to reference them shortly. The first one is fused deposition modeling. In fused deposition modeling, you're going to use a thermal plastic, and it is fed to the machine. And as you can see, the machine has got like one extruder here, which gets hot. And because this is a thermal plastic, when it passes that extruder, it melts. And then when it reaches the surface here, it can sit there. And then there is this bed here which can go down, and the first layer is printed, then it goes a little bit down, and the second layer is printed on top of that, and then it goes lower, and then the next layer, and then finally you can have your model from the bottom to the top. And then if there is, your model is really complicated and you need some support, there can be several of these extrusion heads that they can print the support, and then all together you can have your model, and those supports can be removed later. And with this 3D printing, after additive manufacturing came to market, very, very complicated geometry that has been never able to be done could be made. Then another technology is called polyjet 3D printing. It is the same in the kind of concept, but then instead of using the thermal plastic, you're using a kind of polymer, which is a photopolymer. And then when a photopolymer is a kind of liquid resin, then when it is on the bed, then you have to expose it with the UV lights and it solidifies. So it's the only difference. And then why this 3D printing is like so much hype about it these days? Because the design is digital, of course, and you can email it, you can have it on your USB stick and take it somewhere else. You can make the fabrication domestic, and then you can do fabrication much quicker. But what is the main importance about it is the complexity, that you can make geometries which hasn't been able to be done before, like with a CNC machine, with the molding, with casting, with no kind of form. For example, this geometry that you can see here, the right part is an ABS material, and the left part is a rubber material. This ABS is a hard material, but this one is a soft material. So we have the ability to go to a place and say this amount of material and what kind of properties. Then so far, the technology has promised us that we can make it for you. And then if you can design it, then we can make it. So the focus is now on design. And then it is how you, whatever you have in your mind, to put it in a kind of model in the 3D format, and then send it, and they're going to make it for us. And all the barriers which has been before in the manufacturing, now with the appearance of additive manufacturing, has gone, almost gone. So about a design, there are many softwares which are available now on the market. And for example, one of them which is very easy to use, and I recommend everybody to go and try it, is 123D. And it has different things like design and make, and you can make a 3D or 2D model and just make an STL file and send it to the printer, and then you're going to have it. And the other thing which needs to be focused on is the material, what kind of material we can use. At the moment, more than 120 materials are available on the market that you can use. And what about the future? The future, as you know, traditionally the manufacturing and the design were quite separated from each other. The designers were framing the problems and then making the models and then sending them to the manufacturers. The manufacturers were looking at them that it is possible to make them or not, but there were these iterations all the time, and it made the things very complex and time-consuming. And then after that, they made it concurrent, and the designers and the manufacturers were sitting together, but still, because there were a lot of constraints and they could not understand each other very well, so it didn't really work. But now the aim is to make the kind of designers who will be the manufacturers, and the manufacturers who will be the designers. And with the additive manufacturing, it is possible to do that, because when you sit by your computer, you can design and then send it spontaneously to the printer and manufacture it and see whether the model is good or not, and then if there is a need for redesign, then redesign it. And then I will give one last slide also about the 3D scanners, because we talked a lot about softwares and about modeling. The 3D scanners can also help you in the matter of modeling. That lets you not to start from scratch. There are many objects that you only want to redesign them, so it's better to get a model first with a 3D scanner. It's going to be fast. For example, you can get your face scanned like that. This is not mine, but yeah, it's kind of cool. I have done the same thing, but I didn't have the fun. And then you don't need to start from the scratch. Well, that was it. Thank you very much. If there is any question, I have 1 minute.
Okay, thank you, Ali. But can you tell about the practicalities? So how can school groups work in Fab Lab? What kind of...
Sure. Actually, this presentation, I did it only about 3D printing, but in Fab Lab, we have also the other machines like CNC machines and laser cutters. But on Tuesday, we have an open day from 12 to 6, so everybody is welcome. There isn't any restrictions that you are from Alta or not. But the school groups, if they want to come, they need to book in advance a time that they come for a visit, and then we can allocate that time frame for the school visits. As we're going to have 3 or 4 school visits during November for this course.
Onko kenelläkään kokemuksia tämmöistä vierailusta? Do you have experiences? Onko muilla kokemuksia vierailusta? So tell what happens in there when the school group comes to Fab Lab. What do they do? Do they have a special mission, or do they have to prepare for the visits?
I think the main point is to get the inspiration, because they can see the machines and what they can do. And usually they can have some designs beforehand, and they come there and 3D print it or laser cut it. So it can be really inspiring for them that what they can do, and then how can they relate to the technology.
And one more question about the programs for designing. Are they programs that can be available for school groups in the normal everyday work?
Yeah, for example, this 123D Make that I told you is a free program. There is another one for the 3D design, which is called Blender. It is also free. And for 2 design, there is Inkscape, for example, which is free. These are all the free programs that I named. And also there are some other ones which you need to get a license for them, like Illustrator, like Rhino, and the other ones. Yeah, they can be like easily available and they can use them.
Okay, I'm sure everybody is excited. Onko kysymystä vielä Alille? Lyhyt kysymys. Ole hyvä.
I was wondering about, you talked about how to make it to the 3D printer, but how much does it cost, the printing itself? Is it...
For these printers that I showed, it costs a lot because they're industrial ones. But with the ones that we have, we don't charge at all. Like if you just come to our lab on Tuesdays, we don't charge.
Okay.
So it doesn't cost you anything.
How much would it cost if you would own yourself one?
This printer that we have, the printer itself costs about 1,200 to 1,700 euros. And then the material for 1 kilogram, it costs about 30 euros, which you can do a lot with that. Yeah, it's cheap. But if you want to get these industrial ones, then they're very expensive.
Thanks.
No
okay. A quick one.
Okay, I was wondering...
wait a minute. Wait a minute.
Hello. I was wondering, what can you do with the... what's the difference between the industrial one and the one that you have in functionality? What can you do with the one the 3D printer that you have?
The industrial ones are very accurate and they have really better resolution. You can just make the final product with them and then sell it to the customers. But with the ones that we have, they are for the hobbyists, and then you can mainly do the prototyping. Because with 3D printers, you can do the prototyping, you can do the molding, like to prepare the molds, like it's called tooling, and then you can also do the fabrication, the manufacturing. I think with the ones that we have, it's not really possible to do a very large extent to do the manufacturing, but prototyping is very easy to do with.
Okay, thank you very much, Ali.
Thank you.
And then